So this is going to be chapter 11, sequences in series. So our last chapter. So we were going to first start off with a little bit of a recap of what a sequence in a series is. So first to start off with the sequence. A sequence, all it really just is just a list of numbers in this case. It can also be a list of things that are in order. Oops. In order. Okay, so there's some ordering to this type of sequence. So usually a really good sequence could possibly be like 3, 5, 7, 9. So kind of like a list of numbers that denote the odd numbers. This is just a list. So usually the way that we call these guys, we call them terms. So this guy would be the first term. This guy would be the second term. This guy would be the third term, and this guy would be the fourth term, and so on and so forth until we get to like the nth term. So usually we have a way to denote that. The first term is called A1. The second term is called A2. Third term is called A3. Fourth term is called A4. You kind of get the idea. So that's basically what these terms are, and this is basically what forms a sequence. So usually what we want to figure out, we want to know, well, what is the nth term? Okay, and usually the nth term is a formula. So a formula that involves the variable n. So that means n can be anything that we want, and n would be the number of terms that we're in. So for example, this is the first term, that means n equals 1. This is the second term, that means n equals 2. Here is n equals 3, and here n equals 4. Okay, so usually the way that we want to do it is that we want to start off with, okay, so how can I come up with a number such that, or come up with a formula that for any number I can figure out what that value should be. So for example, if I wanted to figure out what the 72nd term is, well, I don't want to continue on this pattern and continue to do it over and over and over again. I want to make sure that I come up with a formula that will kind of do that for me. So that's kind of what we want to do. Example of a general term will be this: an equals 2n plus 1. This is a formula. So let's see what that gives me. So when I put n equals 1, that means a1, because we're going to plug in 1 for n, is going to be 2 times 1 plus 1. This guy is just going to give me 3. If I want to know the second term, I'm going to plug in n equals 2, a2. It's going to give me 2 times 2 plus 1 gives me 4 plus 1 gives me 5. n equals 3. A3 is going to be 2 times 3 plus 1 is going to give me 7. Or does this look familiar? This is actually the formula for this guy. So if I wanted to know what the 72nd term is going to be, all I can just do is plug in 72 in there. Okay, so the 72nd term is going to be 2 times 72 plus 1. Okay, so 72 times 2 plus 1 is going to give me 145. So the 72nd term is going to be the number 145. So sometimes having a general solution like this, or a general formula, would be really useful. Now the question is, how do we find that general formula? And sometimes it can be difficult, sometimes it can be really easy. It really just depends. So let's first start off writing some terms, and then we'll do some examples. So let's find the first 5 terms of the following sequences. So let's say you have a sub n equals 2n, and then let's say you have a sub n equals negative 1 to the n over 2. Okay, so we want to find the first 5 terms, so that means we're going to start off with plugging in 1. Plug in 1, you get 2 times 1, which gives me 2. Plug in 2, you're going to get 2 times 2, which gives me 4. Plug in 3, you get 2 times 3, which gives me 6. Plug in 4, you get 2 times 4, which gives me 8. And then after that, obviously, you can get 10. So you can kind of see the general pattern here. Okay, you start seeing a little bit of a pattern. What about this guy? So I'm going to plug in this one. I actually have to put it in. So negative 1 to the power of 1 over 2. That's going to give me negative 1/2. A2, I'm going to put in negative 1 to the power of 2 divided by 2. It's going to give me positive 1/2. Now I'm going to plug in A3, negative 1 to the power of 3 over 2. That gives me negative 1/2. Oh, do you kind of see the pattern? Can you predict what A4 is going to be? It's going to be positive 1/2. And then what is A5? That's going to be negative 1/2. So this guy is actually what we call an alternating sequence. Oops, that's not how you write it. Alternating sequence. And basically what an alternating sequence does is that it continues to swap the sign. So the sign is continuously swapping in that case. Okay, so we can have fun with these as many times as we want. To find the formula can be really difficult. We'll do a couple of them. Don't worry about them so much, but just for some fun, for some general fun. And let's say we want to find the formula, find a general formula. Okay, so finding a general formula can be a little bit hard, but we can kind of try to figure it out. So let's say we want to do some examples of this. So let's say you have the sequence 5, 1, oops, that's wrong. 5, 10, 15, 20, 25. So we'll start off easy. So let's try to find a general formula. So in this case, one of the things that we can see is that this is going to be the first term. So I like writing n equals 1, n equals 2, n equals 3, n equals 4, n equals 5. So you kind of see this n value. And when we want to figure it out, well, notice, how am I getting to the next number? Okay, so try to think about it that way. Well, can I possibly relate the previous number or the values of n so that I get the number that I want here? So notice here that if I multiply everything by 5, I end up getting every single one. So if I take 5 times 1, I get 5. 5 times 2, I get 10. 5 times 3, I get 15. So that means a good formula for this guy would be 5 times whatever n is. And that actually is a general formula. Okay? So let's say you wanted to do this one. Let's say you wanted to do 1/2, 3/4, 5/6, 7/8. Okay, so how could we possibly do that? Okay, so here what we got to do is think about it in terms of n. So I'm going to say n here is n equals 1, n equals 2, n equals 3, n equals 4, and so on and so forth. So let's think about, I'm going to break this up into two different parts. I'm going to break this up into the denominator and the numerator. So notice, how can I possibly get a 1 from 1? Well, that's just 1, right? So, but notice that if you see here, when you look at 1 and 1, 2 and 3, 3 and 5, and 4 and 7, how can I possibly think of something that, how do I get from the ends to the numerators? Well, one thing that I'm doing, it seems like I'm kind of adding a 1 or adding a 2, then adding a 3, and that probably isn't working. So, but what about if I think of multiplication? If I multiply this by a factor of 2, for example, what happens? Well, if I multiply this by 2, I get 2. Multiply this by 2, I get 4. Multiply this by 2, I get 6. Multiply this by 2, I get 8. Well, how do I get to the other numbers? Well, if I subtract it from 1, then I get that. So basically, I first want to multiply the n value by 2 and then subtract it from 1. That's going to give me those values. Now, how do I get the bottom part? Well, you can see, how do I get from 1 to a 2? How do I get the 2 to a 4, the 3 to a 6? That one's a little bit more easier to work with because you can see that you can just multiply it by a factor of 2. So it'll be 2n. Okay, so this is basically how you would the general formula for this particular sequence. Now, sometimes they're going to be super easy to do. Sometimes they're not going to be easy to do. So, but I just want you to kind of just think about that. There are some problems where you can kind of try to think about them. Sometimes they're going to be really difficult to do. So just how we have sequences, we also have something called series. And this is very important. So we have something called series. Okay, and series is just a sum of the sequences. So if you have a sequence and I were to add them all together, then I have a series. And another way for a series is what we call a summation. And the summation, the way that it looks like this. So it looks like a funky looking E. Then on the bottom, you have what we call the starting index, which is k equals some number to 5, and then you have some sort of expression like k squared. So basically what this means is that the bottom part is basically telling you the value of k where you're starting. This 5 tells you where you are ending. And this guy just tells you sum. It just tells you add. What am I adding? The squared of the k's. So basically what this means is that you're starting at k equals 1. You're going to plug in 1 in there. So you're going to get 1 squared. Okay, then you got to think about, am I at 5 yet? No. So now I'm going to go to the next one. K equals 2. So then I'm going to plug in 2 in there. 2 squared. Okay, am I at 5 yet? No. So I continue adding. What's the next number? 3. So it's going to be 3 squared. Am I at 5 yet? Not yet. Continue 4 squared. And I keep going until I finally reach the last term, which is 5. And then I stop. And then all I got to do is just add up all these numbers, and that will give me the summation. So it's going to be 1 plus 4 plus 9 plus 16 plus 25. So you see that this is just a sequence of numbers, and all you're just doing is adding up those sequences. So what you're going to end up with is 55. So what we would say that the sum from k goes from 1 to 5 of k squared is equal to 55. That's what that means. Okay, so let's do another one. So you can try this out if you'd like to. So we'll try 2 more. The sum from j goes from 3 to 5 of 1 over j. Okay, and then we'll try out the sum from k goes from 0 to 3 of sine of k pi. Okay, so you can try them out first. I'm going to go ahead and do them. So here my starting point is at 3 now. So that means I'm going to plug in 3 first. Then I'm going to add because I'm not there yet. So now I'm going to go to the next integer, which is going to be 4, 1/4. Not done yet. I'm going to go to 5. So what is this going to give me? So I'm going to take 1/3 plus 1/4 plus 1 over 5. And that's going to give me 47 over 60. So that means that the summation of this guy is equal to 47 over 60. Okay. And now this one. So let's say we're going to start off with k equals 0. So we're going to have sine of k times 0 plus, now we're going to plug in 1. Oh, no, that's wrong. Sine of 0 times pi plus the sine of 1 times pi. So we're not there yet. Plus the sine of 3 times pi. Okay. So when you take the sine of pi, you're going to see that the sine of pi is just going to be equal to 0. I'm sorry, the sine of 0 is just equal to 0. And then I was skipping ahead. The sine of pi also gives me 0. The sine of 3 pi is also going to give me 0. So all of this is going to give me 0. So I'm just adding a whole bunch of zeros. Okay. If I maybe change this to k over 2, it would have kind of probably changed up. Okay. So this is just a brief introduction of sequences and series. And now what we're going to do in the next video is give you 2 different types of sequences that we're going to work with. And we're going to develop series for those problems as well.